Okay guys, so we're going to finish up section 10.4 today with hyperbolas, and it's not just so much hyperbolas anymore. You've learned everything you need to know about the hyperbola, and from the scores that I'm getting, it seems like you're understanding the concept. You seem to be doing pretty well, so we're going to finish up here. Now this is the section for which a lot of students have difficulty with, although I don't know why, because I think that this is very simple, and I suppose it's rewriting from standard form to general form and back, which seems to be the biggest issue for most kids, because it's not hard, but it is quite a bit of work. So anyway, let me turn on my pink pen and let's have a look. And this is the whole formula sheet, so I was feeding you bits by bits per topic. I didn't want to overwhelm you with the whole sheet, but this is a very well done sheet, and I copied and pasted this piece of it just a little while ago into your EDSB so you could use it with the homework. But I will attach the whole sheet too, because this teacher, whoever he or she is, did a really good job on putting this together. All right, so what we're going to talk about today is classifying a conic from its general equation. So what you see is this big long equation, right? And you know, you're going to be given these big long equations. You're going to be asked, is it a parabola, an ellipse? What is it? So you need to know these properties here, and they're really super simple. Now you notice there's a circle on here, so let me just backtrack for a second and say we studied circles a long time ago. All right, and a circle is a conic section. If I take, you know, a double napped cone and I slice, let's see if I can draw something. I doubt it, but so, you know, suppose I take a plane here and cut through horizontal or parallel to, say, the table that this thing, so here's the table, right, sitting on a table, and I cut it parallel to that table, then what I'm going to get are these circular cross-sectional slices. Okay, it's going to be circles. So circles are definitely conic sections. So just keep that in mind, that it is a conic section, and I'm just going to quickly remind you of the general formula, or the standard formula, for a circle. And for a circle, that formula goes like this. It's x minus h squared plus y minus k squared equals radius squared, and the radius is just a number, right? The center of a circle, of course, is at hk, just like all other conics, okay? Again, the radius is just some number, and if the center happens to be at 0, 0, then your standard equation would look like x squared plus y squared equals r squared. So, you know, you might have x squared plus y squared equals 4, for example. Well, the center of the circle I know is 0, 0. The radius of this is the square root of this number, right? So it would be 2. And if I needed to graph it, so just bringing you down a trip through memory lane, my center would be here, and I'd go, you know, 2, 2, 2, 2, right? 2 units away from the center is the radius, and go like that, and there's the picture of your, or the graph of your circle. Okay, so circles are conics, and they are part of this whole idea. Well, guess what? Circles are the easiest ones to spot, because if you're given a general equation and a equals to c, then that's going to be a circle. So what do I mean by that? Well, this big long equation, let's look at it just for 1 second. I want you to know that it goes ax squared plus cy squared. So they group the x squared, y squared, or the square terms, the quadratic terms together. Then they group the linear terms, okay? Linear meaning x to the first, y to the first. And this is just a constant. It's just a number, okay? 5 or something, all right? The coefficients of x squared and y squared are a and c respectively. So if these two numbers are exactly the same, then you're looking at the equation of a circle, okay? The coefficient of x, or the linear term for x, is d, and e for y, and then again, that's just a number. So what I did was I took a snapshot from the homework page from the book, all right? So what you're about to see here, so let me move this over, and that over, and this over. So this is from your book in the homework section. And, you know, you may be asked for number 55, let's say, you know, name that conic section. You know, what is it? And so you say, okay, well, you know, I'm going to look at my A and my C, right? Well, A is 9 and C is 4, so this is not a circle. Now, the rest of these three, you see it says AC equals 0, greater than 0, or less than 0. That means you're going to multiply A and C together. If that product equals 0, you've got a parabola. If it's bigger than 0, it's an ellipse. And if it's less than 0, it's a hyperbola. So we know that 9 times 4 is 36. That's bigger than 0. And so the conic section is an ellipse. In number 56, A is 1, C is 1. They're the same, so that's the general equation for a circle. In 57, A is 4, C is -1. The signs are different. That's your red flag, which makes the hyperbola that much more appealing. The only way you can get a negative number when you multiply is if one number is positive and the other number is negative. So you're going to have different signs for A and C, one way or the other. So since they're different, if I multiply them together just to test, you know, I have 4 times -1, which is -4, and -4 is less than 0, and so therefore we have a hyperbola. Now let's look at 58. 58, there's no x squared term. What that means is that this is not a conic, right? Because again, if you look back into this formula sheet, no matter which one you want to look at, it is always x squared and y squared every single time, x squared and y squared. So I realize that one of the terms is squared, the y is, but there's not an x squared. It's not a conic. Here, look, addition or subtraction, you can move them around, right? Commutative property, as long as you take the sign with it. So, you know, I have a -4 and a +1. If I multiply them together, I get a negative, so I would expect that to be a hyperbola. And let's see, here's another one without an x squared, so that's not conic, okay? Here, 4 times 25 is 100. 100 is bigger than 0. So I would expect that to be an ellipse. Capiche? Pretty simple. So let me erase this and let's look at what happens in a couple of cases. So let's look at this number 55 again. Let me just get that stuff out of the way. Let's look at number 55. We said it's an ellipse because A times C is bigger than 0, right? So let's write the standard form of this equation, given the general equation. So what do? We put our x's and y's together, right? So it's in general form. We want to go to standard form because we have to complete the square to get there. So we're going to do 9x, oops, every time. 9x squared minus 18x plus 4y squared plus 16y equals 0, right? Let me just, maybe if I make that a little finer, I won't get that weird thing with the 4. The 4s always have that little over the top and it makes it look like a 9. Okay, so the idea is that we're going to take this grouping and we're going to factor something out if we can, right? And we're going to do the same thing with this grouping. Oops. And it doesn't equal 0. I forgot the 119. I'm going to move that 119 over to this side. Is that okay? So I'm just adding it to both sides because we know we have to put the constant over there. Alright, so over here, I'm going to work on this first. I'm going to factor out a 9, and I'm left with x squared minus 2x plus the box squared, right? Now again, if this were just me working out this problem, I wouldn't put the box, but I know it helps a lot of you, so if it helps you, put the box so that way you get it right. Right, now over here, for this grouping, I'm going to factor out a 4. So I've got 4 times y squared plus 4y plus the box, still doing it, so it doesn't matter. Okay, so let me make it darker because I can't deal. And let me move my screen over. Oops. over here. A little more room. Okay, so this equals 119, right? And now let's complete the square. So for the first part here, we're going to take half of the linear term, so half of 2 is 1. Oh, sorry. I don't want to complete the square yet. Hold that thought. All right, so let me go back to this. The box. All right, so look, I factored out a 9 here, and I factored out a 4 here, right? So I'm going to put plus 9 times box plus 4 times the box, right? I don't want you to forget that. Whatever you do on one side, you have to do on the other. And if you factor out a number here, you have to multiply it to the box for that particular trinomial. And likewise with this one, I factored out a 4, so I need to multiply this box by a 4. Okay, now let's complete the square. So I'll go back to magenta, and what we're going to have is 9 times x squared minus 2x. Now half of 2 is 1, so we put the 1 in the box and we square it. Well, 1 squared is 1, right? So we'll put those in a second. Now let's square this one. There should be a little square there too. Half of 4 is 2, right? Remember, we don't square them on this side. But over here, we're going to have 119 plus 9 times 1 plus 4 times 4. So remember, you don't square it over here, but you square it over here, okay? All right, so this is going to give us 9 times x minus 1 squared plus 4 times y plus 2 squared equals 119, let's see, 16 and 9 is 25, so 119 is 144. Right? And remember, we have to have a 1 on this side, right? So that means we need to divide every term, both sides, by 144. And when we do that, those cancel and we get a 1 on the left. So I'll just rewrite it. 9 goes into, oops, let me get my calculator. 9 goes into 144 16 times. So I'm doing 9 goes into itself once, it goes in here 16, right? 4 goes into itself once, it goes in here 36. So what I've got is x minus 1 squared over 16 plus y plus 2 squared over 36 equals 1. And that's my standard equation of the ellipse, right? Now if I needed to graph this thing, right, we could do it. We know that the bigger number is under y, so we're going to have a vertical major axis, and we know the center is at 1, negative 2, so, you know, we could, right, at 1, negative 2 is the center, call that negative 2, that's 1, right? If I wanted to plot the vertices, then I would have to go plus or minus 6 from the center, so 1, 2, 3, 4, 5, 6, so I'd have a vertex here, and then 1, 2, 3, 4, 5, 6, another one here. Well, that's off a little bit, isn't it? 1, 2, 3, 4, 5, here, 6, sorry. All right, and so this would be my vertical axis, and then I could find my minor axis by writing this as 4 squared, right? And so I'd go 1, 2, 3, 4 from the center and plot a covertex, and 1, 2, 3, 4 and plot the other covertex, and you know, looks terrible, but anyway, you get the idea. Now, I know you guys are getting good at this, and that's wonderful. However, you're not used to going from this form back to this form. So let's do that real quick, shall we? So let me just get rid of all of this, and let me just get some things out of the way here. I didn't want to do that. Okay, so I'm going to delete this. I just like to have a lot of room. Go back to blocking. Okay, so what did we have? We had x, was it x minus 1? Yeah, x minus 1 squared over 16 plus y plus 2 squared over 36 is equal to 1, right? And you may be asked in your WebAssign homework, you know, write the general equation of the conic, of the ellipse, the circle, whatever, given the standard form. It's really easy. It's some work, but it's not hard. The first thing you want to do, remember when equation solving to get rid of fractions, is just to multiply every term both sides by the product of all denominators. So I have a denominator here and here, and they don't match. However, I don't even have to come up with the big number, 16 times 36. I can multiply this term. I can just leave it like this. I want to show you something, over 1, right? And I multiply this term. Here, let me move this over a little bit. So let me just move that plus over a tad. I'm going to put it over here and go back over here. So I'm going to multiply this term by 16 times 36 over 1. So you can think of it like that if you want to. And I'm going to multiply this side by 16 times 36, right? Whatever you do to the left, you've got to do to the right. And this is what I want you to see. So look, if I multiply these, the 16s cancel, right? So what I'm left with is 36 times x minus 1 squared for the first term. That's all that's left, right? 36 times this. Bring down the plus. Over here, the 36s are going to cancel. So I'm left with 16 times y plus 2 quantity squared. And 16 times 36 is 576. Okay, so this is 576. And you might say, well, hey, that doesn't look like the general form, right, that we had. It will. You have to work on it. So what you're going to have to do is you're going to have to expand these binomials by foiling them out. So I'm going to have 36. Now, I'm going to FOIL this out quick because you guys should be okay with foiling by now, all right? So this is going to be x squared minus 2x plus 1 plus 16 times y squared plus 4y plus 4 equals 576. And now I've got to distribute, right? So if I distribute 36 to every term here, I'm going to have 36x squared minus 72x plus 36. And now here I've got to distribute the 16 to every term. So I'm going to have plus 16y squared plus 64y plus 64 equals 576. And now I've got to get my x squared terms together, my y squared, my x and y squared terms together, and my x and y terms together, then my constant, right? So I'm going to do that. So I'm going to have 36x squared plus 16y squared. So what I just did here is I just put those two together, right? In that form, right? ax squared plus cy squared plus dx plus ey plus f equals 0. That's the form I'm striving for. Okay, now I'm going to do the same thing with the linear term. So I've got negative 72x plus 64y. So I took care of those. And now 36 and 64 is 100, right? So plus 100 equals 576. And my right hand side is not 0, so that means I need to subtract 576. When I do that, I'm going to have 36x squared plus 16y squared minus 72x plus 64y minus 476 equals 0. So this is a negative 576 and a positive 100, making it negative 476 on the left. And right now, you're probably still saying, well, that's still not the general form that you gave us. In fact, let me see. Here. Oh, it logged me out. Come on. Okay, so how about we go to WebAssign. We'll go here. So bear with me a second. Because, you know, me and my bright ideas, right? I deleted that one equation. And I'm just going to bring this up. Chapter 10. 10.4 exercises, right? Okay. And it's all the way at the end here after the applications. Here we go. Okay, so this is the one, this is what I'm trying to get here. All right. In fact, I'll just make a little snippet and pop it right in there so that way we have it. So that way you don't have to get dizzy watching me going back and forth. Copy. And back to my whiteboard. So this is what I'm trying to get. And right now, they don't look familiar at all, right? So what that means is that I need to find something that divides into each one of these coefficients evenly. How about 4? 4 goes into 36, 16, 72, 64, and 476. So that's exactly what I'm going to do. 4 goes, I'm going to divide every term, all right, by 4. So let me just write it here. And again, I apologize about the 4. It's, I guess, the way that I handwrite, it looks like a 9, but these are 4s. 4s. All right, anyway, 36 divided by 4 is 9x squared. That's what we're left with, right? Plus 16 divided by 4 is 4y squared. You see it's starting to look better. 4 goes into 72 18 times, so that's negative 18x. 4 goes into 64 16 times, so 16y. And 4 goes into 476 119 times, and there we go. Okay, so we went from the standard equation of an ellipse back to the general equation of the ellipse. So it's important that you can go back and forth. Not only is it an excellent way to practice your algebra skills, which you need to be really, really good at for when you go into calculus, but you know, it also helps you become more fluent in that, going back and forth. All right, so really good exercise. And if I go back here to the ebook, that one had an answer, and it was an ellipse, and unfortunately it didn't ask you to, you know, put it in standard form and then go backwards again. But let's see if I can find another one here. Okay, so here's one, right? Looks like a hyperbola to me because there's a minus here, right? X comes before y, so I know a whole bunch of things about this hyperbola. Well, we do, right? You know a whole bunch of things about it. So let's rewrite this one into general form. So let's just make it a little bigger. Okay. So again, you know, I have this equation, and I have different denominators, but that's okay. I'm going to multiply each term, both sides, by 9 times 16. If you want to do 9 times 16 and get the number and do that, that's fine too. You know, whatever floats your boat. But I'm going to do 9 times 16 times x squared over 9 minus 9 times 16 times y squared over 16 equals 1 times 9 times 16, because whatever I do to the left, I got to do to the right, right? And for this term here, then 9's cancel, and I'm left with 16x squared. I'm going to bring down that minus. For the blue term here, the 16's will cancel, and I'm left with 9y squared. And over here, I've got to use my calculator. Didn't I just calculate that a minute ago? 9 times 16, no, is 140, yeah, 144. So this one is 144, okay? So I'm not quite at that general form yet, but I'm getting there, right? And guess what? The rule says, or the formula says, again, that we need this thing as ax squared plus cy squared plus dx plus ey plus f equals 0. So I know my a is 16 and my c is negative 9. By the way, a times c is a negative number, so that just further validates that it's a hyperbola. Anywho, there are no linear terms. It's okay. They're 0, okay? The coefficients of d and e are both 0. That's why you don't see plus dx plus ey, okay? So that's fine. And finally, we would have to write this with 0 on the right, so that means I have to subtract 144. So you'd have 16x squared minus 9y squared minus 144 equals 0. And that would be the general equation for that particular hyperbola. All right? So you go back and forth, and then of course you could take this form, right? And you could write it back in standard form. You'd add 144 to both sides, right? You would divide everything by 144, so that way the right was a 1. And you'd end back up with this thing here. So you can go from here to here, or here to here. And again, I think there are just a few. Most of them, I think you just have to determine whether or not it's a circle, an ellipse, etc. All right? And by the way, let's just see one more circle problem. This is not a circle, okay? It's not a circle. If there's a minus in between, it's not a circle. It's a hyperbola, right? Because the signs are different. So circles have a plus in the middle, like ellipses do. So be careful with something like that. It's not a circle at all. But I don't want to add a note. Yeah, this is pretty much curve sketching here. Let me go back down to here for a second. Okay, so here's a circle, right? Number 56. So let me copy this. Sorry about all the copying in the video, but you never know what's going to happen. So paste. So here's the general equation for a circle. Right? Now we want to write this in the form that we know, this x minus h squared plus y minus k squared equals r squared, right? And the question is, can we do it? Of course you can. So guess what? Let's do that, shall we? So the first thing I want to do is I want to get, again, we're going to have to complete the square, just like you did with the hyperbola and the ellipse and everything else. So we're going to get our x terms together. And we're going to get our y terms together. And we're going to throw our constant over to the other side, right? And then now to prepare to complete the square, we're going to add boxes, right? And thankfully we don't have any coefficients on x squared and y squared, so I don't have to worry about multiplying to my box on the right hand side. So I'm just going to complete the square as we go, all right? So we've got x squared minus 4x. Now half of 4 is 2, so you're going to put 2 in the box and square it, right? Plus y squared minus 6y, and half of 6 is 3, so we're going to put 3 there and square it. So over on the right we're going to have 23 plus box, right? No need to multiply by a number because the coefficients were 1. 2 squared is 4, so I've got to put that there. And 3 squared is 9, so I've got to put that there. So what I have here then is x minus 2 quantity squared plus y minus 3 quantity squared is equal to, so what we have is 23 and 4 is 27 and 9 is 36. So here's my standard equation of a circle. I know the center of this circle is at 2, 3, and I know the radius is 6. The radius is the square root of this number. Remember, this is r squared, so when you want r, you got to take the square root. All right, and if I had to, oh gosh, this is terrible. I would go over 2 and up 3, and I would plot my center. I want pink. So 2, 3 is here. And from my center, I would go right, left, up, down 6 units, right? And then I would connect. And I would have my circle. But anyway, that's not the point. I know you can graph them. The point is, can you take the general equation and get this? Can you take this now and get this back? Of course, all you have to do is expand these out and put it of the form ax squared plus cy squared minus, or sorry, plus dx plus ex plus f equals 0, and you get back to this form right here. Okay, so I hope that helps, and let me know if you have any questions. Talk to you soon.